Welcome dear students, this lecture is about the concept of the resonance. My dear students, resonance is a concept related to both inorganic as well as the organic molecules, but in this lecture we will focus on the resonance concept related to the organic molecules. There are so many organic compounds that cannot be accurately represented by their single structure, just like one of the famous example is benzene. It is hexagonal. It has all sp2 hybridized carbons. And my dear students, there is a proposed structure of benzene, something like this. It was proposed by Kekule, so it is also called as the Kekule's structure. Now, this one is a proposed structure of benzene. But we know in benzene, the delocalization of electrons takes place. The electrons, they are not localized, they are not between any two carbon atoms, but they keep on moving in the whole molecule. So that's why, due to delocalization of the electrons, these pi bonds may be shifted, something like this. And due to shifting of these pi electrons, due to delocalization of the electrons, another structure of the benzene can arise, this one. Now this one is the structure 1 and the other is the structure 2. These are two proposed structures of the benzene. My dear students, these two structures, they have same shape with same bond angles. They have same position of atoms. In both structures, you can see each corner of the hexagon is occupied by a carbon atom which is attached with one hydrogen atom, and the formula of the benzene is C6H6. They have same energy, they have same number of bonds and same number of bonding electrons. Then what is the difference between these two structures? Basically, they are different with each other with respect to the arrangement, or you can say with respect to the bond pairing scheme, or the scheme of the pairing of the bonded electrons. So there is difference in the arrangement of the bonds, or you can say the pairing scheme of the bonding electrons. The double bond is replaced by single bond here, and same this double bond is replaced by single bond. So the bonding arrangement is different. My dear students, the phenomena in which, now listen very carefully, it is definition of resonance. The phenomena in which two or more structures, they have same shape, same position of their atoms, they have same energy, same number of bonds and total bonding electrons, but they differ with respect to the arrangement or pairing scheme of the bonding electrons. These two structures are called as the resonance structures, and the phenomena is called as the resonance. Now the resonance usually arises because of the delocalization of electrons. So delocalization of electrons is responsible for the resonance, and the resonance is shown with the double-headed arrow, just like something like this. It is a double-headed arrow which is a symbol of the resonance, and the resonating structures are connected through this double-headed arrow. Please do not confuse it with this arrow. This one is the representation of a reversible process. This one is a different arrow. Both these arrows, they carry entirely different meanings. It is a symbol of the reversible process, and this arrow is a symbol of the resonance. And these two structures that are present, that exist due to resonance and delocalization of electrons, these are called as the resonance structures or resonating structures, or they may also be called as the canonical structures. So these structures have three names: resonance structures, resonating structures, or canonical structures. My dear students, can we find benzene in the laboratory in form of any of these two structures? So dear students, you will never find benzene in form of any of these two structures in the laboratory. You will just find these two structures in the books. It means these structures, which are called as the resonating structures, resonance structures, they have no actual existence. Rather, they are just proposed theoretical structures to show the delocalization of the electrons in an organic molecule. Then a question arises, what is the actual structure of benzene then? My dear students, the actual structure of benzene is considered as the resonance hybrid of its resonating structures. Now, resonance hybrid is the structure having properties which is in between the two resonating structures. Resonance hybrid is not a mixture of two structures. Listen very carefully. Resonance hybrid is not the mixture of the resonating structures. Rather, it is a structure in between the resonating structures, and it is the structure which is most, or you can say, closest to the actual structure. So, what is the resonance hybrid structure of benzene then? It will be in between these two resonating structures, and it is shown something like this. As the shape will remain hexagonal, but we will show a circle inside the benzene ring, and this circle basically shows the movement of six delocalized pi electrons. So this circle shows that the pi electrons are revolving in the benzene molecule. They are delocalized. They do not stay in between any two carbon atoms of the benzene. So these are the resonating structures, and this one is the resonance hybrid structure of the benzene, closest to the actual structure of the benzene. Now, my dear students, these resonating structures are showing carbon double bond carbon in the benzene and carbon single bond carbon in the benzene. You know that carbon single bond carbon has bond length of 1.54 angstrom, double bond has 1.34 angstrom. What will be the bond length in the actual structure of the benzene, which is experimentally determined through X-ray diffraction? The actual bond length is basically 1.39 angstrom. So the actual carbon-carbon bond length in the benzene does not match with either the double bond or single bond length. It is something in between these two. It means that in benzene, the bonds are in between the single and double bonds. Mean the bond is stronger than carbon-carbon single bond, but the bond is weaker than carbon-carbon double bond, and the bond length is in between these two bond lengths. So we say that this is basically resonance, and the bond order between any two carbon atoms of the benzene, that will be not 2, that will not be 1, rather it will be considered as 1.5, in which there is one complete bond, and the zero point 0.5 bond means the resonance. The electrons, they are delocalized. they do not stay between the carbon atoms. So the bond adder actual that is considered in benzene as 1.5. Now, my dear students, which of the following these structures is the most stable structure? The resonating structures, they have equal energy. So in the energy diagram, we will show them at the same position because they have same energy. We have already discussed that. These are two resonance structures. As the resonating structures, they always have high energy as compared to the resonating hybrid, which is present at the relatively lower energy. So the resonating structures, they are unstable as compared to the resonance hybrid, which having low energy is more stable and less reactive than its canonical structures. And my dear students, the difference, because hybrid is present low energy, so you will show it at the low energy, and the difference between the energy of the resonance hybrid and its canonical forms, that is called as the resonance energy, which shows the stability of the resonance hybrid structure. In case of benzene, what is its value? Let us calculate. The resonance energy is basically calculated by calculating the experimental and theoretical heat of combustions. So you can say the resonance energy is equal to the heat of combustion minus heat of combustion. This one is the heat of combustion which is actual, which is experimentally determined. In case of benzene, the heat of combustion that will be experimentally determined, it will be called as the actual heat of combustion, and the heat of combustion that will be just theoretically calculated on paper, that will be called as the theoretical heat of combustion. This actual heat of combustion is actually the heat of combustion of the resonance hybrid. And this theoretical is the heat of combustion of the structure 1 and 2, mean the heat of combustion of the resonating structures. Now, when we experimentally calculate the heat of combustion of the benzene, that comes out to be 759 kilocalories per mole. And when we theoretically determine the or calculate the heat of combustion of these two resonating structures, that comes out to be 797 kilocalories per mole. As they are at higher energy level, so their heat of combustion will be high. This is at lower energy level, its heat of combustion will be low. And when we will calculate it, the answer will be almost 38 kilocalories per mole. This is the resonance energy of the benzene. So this is the difference between the energies of the resonating hybrid and the resonance structures, and that will be 38 kilocalories per mole. And when you will calculate it in kilojoules per mole, you know that 1 calorie is equal to 4.18 joules. So when you will calculate it in kilojoules, it will be almost 152, almost kilojoule per mole. That is the resonance energy of the benzene. So we will say that the resonance hybrid structure is 38 kilocalories per mole more stable as compared to its resonating structures. Or you can say this structure is 152 kilojoule per mole more stable as compared to its resonating hybrid, and this structure is this much at the lower energy level as compared to its resonating hybrid. So the resonance, there are so many other organic compounds in which resonance can be seen, just like in case of acetate. There are so many inorganic molecules in which resonance is present, or inorganic ions, just like carbon dioxide, phosphate, sulfate. They have all the resonance and resonating structures. But this topic, that was the concept of resonance with respect to organic compounds, and especially among the organic compounds with respect to the benzene. There are not just these two proposed structures of the benzene, there are many proposed structures, many resonating structures of the benzene, like the diverse structures are there. There are so many others, you can Google them. You will find that there are so many other structures, proposed structures of the benzene, but the actual structure of the benzene is still unknown. This one is the structure which is considered as closest to the actual, but you cannot say that this is the actual structure. Benzene in the laboratory, the actual benzene is not in this form. Then what is the structure of the actual benzene? That is still a mystery to be solved. So that was the concept of the resonance. If you find any problem, you can ask in the comment section. Till then, take care.